All right, people. So we're going to move forward with acceleration right now. We're going to move forward, okay? Now, if we look on the board, well, camera's already up. The thing's already up. If we look on the board, I'm going to post your physics tables today, and you can print them. And if you can't print them, just look at them. When you come to me, I'll print them and I'll hand them to you. But there are a lot of formulas on your physics tables, and the formulas are found on page 2. And these things are going to light up here in 1 second. And the formula that I really want you to look at is our next one. And that is this acceleration formula right here. Now this one, that formula we're going to be using a lot, okay? That's our introductory acceleration formula. And then the other one we're going to use with the car and do a little diagrams. So this is the formula I'm going to use right now. I'm going to give you just 2 problems to work with this formula, okay? Now, xf equals xi plus vit plus 1/2 at squared. Now this is a formula that you would not be able to brain out, okay? What I mean is a lot of these problems so far in this class you've been able to do in your head. For example, a car has a velocity of 3 meters per second. How far away will it be in 3 seconds? 3 times 3 would be 9 meters away, right? But if I asked you, hey, how far away will a car be if it started 50 meters away from you, okay, and then began accelerating at 2 meters per second squared and did that for 6 seconds? How far would it end up away from you? You wouldn't be able to answer that off the top of your head. But you can use this formula, okay? I should have put that constant symbol on the V. All right. Now, here's an example of how you can do it. Let's say we have a skateboarder, okay? And they're skating across some flat ground. And then they're in a skate park. And then they come to an incline, okay? So right here, they're going to have a constant velocity. And then when they hit the ramp, they're going to have a negative acceleration. Don't you agree? So if we were doing then, let's say, a particle diagram, these dots would be the same distance apart. Then as they hit the ramp, the dots will slowly, depending on how steep the ramp is, begin getting closer together. And it's got to stop. This is stop when its velocity equals 0. Does that make sense? So we could do a problem like this. We could say a skater skates at 2 meters per second for 5 seconds. Then comes to an incline and begins to negatively accelerate. Over here they have a negative acceleration of 0.5 meters per second, okay? And then they do that for, I don't know, 4 seconds. Then I could ask you, how far away total, or how far total did this skater skate? Now this skater in the problem I gave you didn't necessarily stop. They just decelerated at a negative acceleration of 5 meters per second for 4 seconds, okay? So I'm going to work this problem, and it's just like the 2 little problems on your worksheet. So here we go. The skater initially was skating at 2 meters per second before they got to the hill. And they were doing that for 5 seconds, right? Now, this T right here, this is a plus sign, people. That's a plus sign. But this T and this T right here, are not the t that you're given. These two t's are not the t that I gave you in the problem. The time I gave you in the problem is the time that they were skating before there was any acceleration. This t right here and this t right here are the time that the skater was accelerating, or negatively accelerating, or decelerating, or slowing down, whatever you want to call it, okay? So this t right here, 2 meters per second for 5 seconds, you just use that to calculate how far they went before they got to the ramp. So 2 times 5, 10 meters is the initial distance that they skated before they got to the ramp. Does that make sense? Plus, now the rest of the problem, this whole part of the problem right here is the acceleration part. This is the math from the ramp. So initially, when he hit the ramp, he was going 2 meters per second. That's the VI. And he was negatively accelerating for 4 seconds. So we put 4 seconds for that t plus 1/2. The acceleration was negative 0.5 meters per second squared. So plus 1/2 times negative 0.5, and then your t squared again, 1/2 a t squared. That's the t. The t is always the t related to the acceleration segment of the problem, okay? Now I realize this is dirty. Some of you can't see it, so I'm going to finish it with you. Try to write as clearly as I can. But what I'm telling you is this whole segment of the equation deals with the hill, when the person is on the hill. So 10 meters plus, all right, in this bracket, 2, that's 8 plus 1/2. All right, 4 squared is 16 times negative 0.5, right? That's negative 8, and 1/2 is negative 4. Does that make sense to everyone? 8 plus a negative 4. Now, if you don't know how I got that 4, 1/2, 0.5 times 4 squared. 4 squared is 16. Negative 0.5 of that is negative 8, and half of negative 8 is negative 4. So 8 plus negative 4, or 8 minus 4, 4 meters is all that's covered on the ramp when the skater's slowing down. He went 10 meters before he hit the hill, or she, who cares? Maybe it's roller Jen. Do you know who roller Jen is? No, Estrogen, that's it. She's a roller skater on YouTube. So 10 and 4, the final distance that skater skated total was 14 meters. Now, if you're confused at home, just watch the video again, okay? And I'm going to slip you a little worksheet with this. It's only like 2 problems to practice, so whoop-de-craps, 2 problems. Good luck.